Great. So let's go. I'm so excited to have you here with us today at Pentera's webinar. And we're going to talk about the story of how we found these two CVEs in FortiClient. But you know what? Before I start with this, I just want to share a quick story with you guys. So it just happened the other day, actually. I was sitting in the living room. It was pretty late at night already. And my wife just came out from the kids' room. So when she went out, I looked up from my phone and looked back down just to watch, some funny memes. But, I couldn't explain it. Something just felt off. Something felt weird. And I didn't know how to explain it. So I looked up again, trying to understand what is it that was bothering me. And there it was, a huge spider right behind my wife. It was one of those moments that reminded me how important it is to listen to our gut feelings. And I know it might sound weird to you, but I had the same feeling looking at this list of 40 clients named pipes. And actually, that's how the story of these two CVs starts. My name is Nir Chaco. I'm an electrical engineer, a former Red Team leader, and currently a security researcher here as part of Pentera. So to be honest, I just like to break stuff and see what happens. Other than that, I'm a huge Harry Potter fan, and I just want to remind you that asking questions is cool. So if you have any question during this session, please write it down in the Q&A section, and I will make sure to answer all of your questions by the end of this session. We will have a dedicated time to do that. So Windows named pipes. We're going to talk a lot about them today, but before we do that, I just want to establish a few key terms. So first of all, I will start with the IPC, inter-process communication. And that means basically all of the techniques that allows processes to communicate with one another. It can be through shared memory sections, it can be through internal sockets, and through named pipes as well. In Windows, Windows named pipes. They work on top of the NPFS, named pipe file system. And in this file system, like any other, you have the ACLs, ACL Access Control List. This is the feature that allows you to put specific permissions to these named pipes. So you can look at it like any other file, basically, where you give read access or write access, or both of them, basically, or none, by the way. So you might think of it like any other file. So, but the path to it is just a little bit different. It looks more like this. If you want to give a look and see which kinds of name pipes you have on your computers, on your servers, you can use, for example, Pipe Viewer. That's a tool, a GUI tool, that allows you to view named pipes and the permissions that is attached to them. So you can see the named pipe and you can see who or what can write or read from these named pipes. So the question arises, why is it so much of an interest to us? Let's give it an example from the security perspective. So let's say that you walk into a bank and you want to deposit a check. Now, the check is the named pipe, and you can write and read from it. So you can write whichever amount of money that you want, and you can write whichever account that you would like to deposit the money to. That's on the one side of the named pipe. On the other side, the bank teller, let's say, can only read this data. You wouldn't want him to be able to edit this. But if we will give another example, so let's say that the bank counter is the differentiator, and now you have on the one side all of the bank employees. All of the bank employees from this side of the counter can just read the data. But all of the bank customers on the other side of the counter can now both read and write to this check. You wouldn't want anything like that to happen because you know that any criminal can just come, change the details, and make sure that you will deposit the money to their account. And that's exactly what happened in FortiClient's named pipes. What you see here is the FortiClient's named pipes with the permissions that allowed read-write access to all authenticated users. It didn't really matter if it was low privileged user, a high privileged user, whatever, all of them could read and write to these named pipes. And sometimes it's not so much of a worry because that's okay. The process is in low privileges anyway, so it doesn't really matter if you speak with it with low privileges or high privileges. But in this case, the other side of the named pipe was services with system privileges. And that's the point where like my spidey senses were going crazy. Okay. And the reason that it was like that was because of this equation. So what you see here is that if you have named pipes with read-write access, which we have, and service with system privileges on the other side, which we have, and an exposed service API, then you can get an LPE, a local privilege escalation. You have the potential to get it. But what about the exposed service API? First of all, we need to know more about the API. The API is the way that these processes communicate with one another. So how can I speak with a process on the other side, right? What's the language that I can use? So the question actually is answered by my history, let's say, with network engineering. And I know that the best way to learn about protocols is by sniffing the network. So of course, it jumped to my head. Let's use Wireshark. But what's like a Wireshark for named pipes? The answer is IO Ninja. It's a very powerful tool. You can do a lot of stuff with it. But for our example, it allowed us to monitor and sniff the communication on on the named pipe that was on our interest. Now, you probably know this if you ever used Wireshark, that you get a lot of data there. It's hard to understand what is relevant, what is less relevant, and what you should do with it. So I decided to put my focus on specific parts. In this case, looking at FortiClient VPN, I noticed that there are grayed out buttons that I couldn't click on with my low privileges. And I know as a security researcher that beyond the obstacles awaits the reward. So I was like, okay, that's interesting. Let's go look how this thing works. So what I did was basically starting to sniff the communication in the named pipes by clicking these buttons and trying to figure out what's going on there. So I went on with the clear logs and export logs uh, functions because they seemed more simple. Now, starting with the export logs, first of all, what you can see is that the named pipe was FortiClient dblog daemon. And the process that wrote to this named pipe was FortiClient. And it wrote there 0101, and then a bunch of zeros. Then on the same named pipe, we got an answer from the process or the service of fcdblog that returned 01010080 and so on. So what I can understand from this point is that there are specific commands for exporting logs and to get a response of probably a success of the operation. Exporting logs is something that I don't have any interest in because I can do this with low privileges. So I went on to check the clear logs operation. And I saw basically the same concept. It's just that now this sort of opcode of an API changed. Before that, it was 01001 and a bunch of zeros, and now it's FF, and again, a bunch of zeros. So I looked at it and I was like, okay, again, from the network engineering part, I can use a reply attack. So I can send the exact same message and I can only expect the same results, right? So what I did, I used pipe viewer, again, the same one that showed me all of the, like the full list of the named pipes, to try and communicate with this named pipe. And there's a feature called chat. So I tried to chat with this pipe, and I immediately got disconnected. Even when I tried another named pipe and tried to send something to it, I got disconnected again. So it didn't work. So bad luck for me, right? Until this point, I was pretty optimistic, to be honest. I thought it would be like a low-hanging fruit and it would be easy enough to try and catch it. But in this point, I didn't know what was it that blocks me. So of course, I went on and reverse engineered FCDB log to try and understand what is the mechanism that blocks me. What I noticed when I went on and found the place where they handled the pipe messages was that they first checked the peer info. They used the get instance peer info function. And this function basically checks the other side of the pipe. It checks who is it on the other side of the pipes that send me messages. And it's not only that, but then it filters out the peers that are not FCT app, FCT FortiClient. So now the question is, how can it know that I'm not really a legitimate FCT app? And the answer is that it filtered out the path in which this process is executed. In this case, it was FortiClient installation folder under program files. So looking at this, I was, okay, let's go first, make sure that I understood it correctly. So I copied all of the pipe viewer files into Fortinet's folder, of course. And then you can just look at it. I was able to communicate, even when I send something that is not a proper opcode, let's say. But you might say to yourself, yeah, that's cool, but you can't just copy anything that you would like to into program files. And you would be absolutely right. I can't. You would need administrative permissions to do so. But again, we're not the type of guys that just stop in front of an obstacle. So the first thing that came to mind was that the context in which FortiClient is executed is the same as the one of the user, which means that if I'm a low privileged user running FortiClient, FortiClient runs with inside my context. It means that I have control over this process. So now I can perform code injection attack. It can be anything, but process following for me was the easiest one to test. In process following, we basically take the original code section in the memory and replace it with a malicious code instead. This malicious code will try to communicate with a named pipe under the wrapper, under this sort of a costume of the FortiClient process. And at this point, we actually did get an exposed service API. And that right there is the first CVE. Now, this is the first vulnerability that we're talking about. But before we continue to the next one, let's talk about exploitation, because vulnerability is a nice concept. And now I know I can clear the logs, but what else can I do? I want to do something that is more interesting for me as an attacker. I went on and I saw that the other button was the restore of configuration. And now it becomes a little bit more interesting. What I saw when I sniffed this communication again, I saw the same concept of an opcode. But then after this opcode, I saw a wide string. So the string started off with -f, usually a flag for file, and then a path to a file, which was, of course, the file of the configuration file. Then it also used the flag of O. I can only guess it's an operation, and then import. So now we know we can sort of interact with it, and we can change maybe the path to this configuration file. But something here, oh, so before that, I just wanted to show you that there's the fcconfig executable. That's an executable that FortiClient uses to actually load the configuration. So what we saw before as part of the string is all of the arguments that fcconfig will get while trying to load this configuration. But looking at again on the opcode part, I saw this weird thing. I saw this 16. Before that, we know the opcode was like 0101 and a bunch of zeros, or FFFF, and again, a bunch of zeros. What is this 16 doing over there? So I looked it up, and apparently it's part of the registry values that FortiClient has. And 16 is the hexadecimal app type for a specific command, for the fcconfig command. Now, knowing all of this, I wanted to figure out what I can do when I load a malicious configuration. One of the first things that I noticed, by the way, the configuration file, I don't know if you know it, but in this case, it's an XML file. So it was pretty easy to understand how it goes. And I saw that, first of all, it would be very easy to change the VPN server. But that's something that a regular user can do as well. What a regular user can't do is to change the warn invalid server certificate. This is a flag that actually sets the program to warn the user about an invalid certificate in the server, which means that if an attacker would change the VPN server, the user will certainly get some sort of a warning. But if I would change this from 1 to a 0, then what might happen? If we will combine all of the things that we talk about until this point, we can see what we can do with it. So let's see a short video. Here, first of all, you can see the legitimate server. You see valid VPN server. And more interesting than that, you can see that I can't click on this checkbox. I just can't check it. What we will do now is we will perform the code injection attack. In this code injection attack, I put a malicious code that will communicate with the named pipe and will restore, as you can see, the configuration using the same opcodes that we saw earlier. And now we have the hacker malicious server as the VPN server. And more than that, it won't warn the user about this change. Even Fortinet says here that attackers could steal your information, such as credentials, credit card details, etc. And of course, they are right. So if I will put a malicious server of my own, I will get on the other side the clear text credentials of this user. But it's not the only thing we can do, right? So let's look at this. I went over this XML file, the configuration file, and I found out this very strong IT utility. The IT team of a company can set an on-connect or an on-disconnect script as part of the configuration. So now if you're a user and you connect to the VPN, they can automatically map a remote shared folder to your computer. And on disconnect, they can unmap it again. But as you might know, any strong IT utility is a strong hacker utility as well. In this case, we can use it to gain persistency over the workstation. For the user, well, it wouldn't see anything because it would get executed in the background. And from the perspective of security mechanisms, it's something that is part of the process tree of this legitimate application. It would be under FortiClient. So now it's not only persistent, but it's hard to discover. It would look something like this. So the user will try to connect to the VPN, and then the on-connect script will get executed. And as you can see, it will trigger the calculator in this example. Fun fact about this. So the configuration is shared by all users on the same computer, which means that if you have a low privileged user with an on-connect script that an attacker can change, now the same script would be in the high privileged user. So if you have the same computer, two different users, one of them with high privileges. Now, when the high privileged user will try to connect to the VPN, this malicious code will run under is context, which means that now it's an LP again. I think we covered a bunch of ways to exploit this vulnerability. So I went on and asked, okay, what is it out there other than the FCDB log service? And the answer was, well, we have 40 settings as well, so let's have a look. And the reason it was interesting for me is that because I saw in Procmon, which is a sysinternals utility, I saw that 40 settings changed a very sensitive registry values. So it could be the server certificate, the enabling of the SSO function, Azure auto login, and a lot of other registry values as well. So again, it was kind of interesting. So I went on and sniffed this communication as well. But this time, of course, it was encrypted. They gave me some hard life in this research. But anyways, what I wanted to do, again, is to figure out how to go and basically crack this barrier again. So I looked again on the part where they handled the pipe message. And what I saw in 40 settings is that they used this function. Every time the data came in or went out, they called this function. And I saw the logic and understood that it's an encryption or decryption function. But it was more interesting than that because they used a hard-coded encryption key, part of their executable, and it was the same for all of the previous versions. And now, using both the logic of the encryption function or decryption, it was the same because they used XOR basically. And this key, I was able to make this function again and use this key to decrypt the data. Now what I saw is that part of this data, they had the registry keys and the values that they set. So by the way, this right there is the second CVE. Just being able to understand this communication and finding the hard-coded encryption key was the second vulnerability. But combining these two vulnerabilities allowed me now to change all of these registry values, basically affecting the entire system. That makes it 2 out of 2 vulnerabilities. So the first one was an improper access control. It allowed all authenticated users to read and write to sensitive named pipes. Using this alongside a process injection, it allowed us to bypass the custom security barriers that Fortinet put in their FortiClient application. The second vulnerability was the hard-coded encryption key that allowed us to decrypt all of this communication and then to also take part and change the registry values. Let's talk a little bit about the mitigation, right? So first of all, I would highly suggest you to update your FortiClient version to 7.4.1 or higher than that. Also, make sure that your EDR blocks code injection techniques. It's something that is well known, so it should be able to do that, but you should make sure and validate it, that it actually works. And third, we talked about fcconfig as the utility that FortiClient uses to load the configuration, which means that this is the tool that actually approaches the configuration file. So make sure it doesn't try to get like weird sensitive files from the system. Key takeaways. Well, I will start with the developers in this session because I would highly suggest you to isolate user-level operation from elevated processes. And if it's not in like deep need of your system, don't take security into your own hands. Use the security mechanisms and measures that are already part of the operating system. They are usually strong enough, and you should combine it with your proper design. Other than that, for the red and blue teamers and security researchers here, I would highly suggest you to look at proprietary mechanisms and custom barriers because a lot of time they pose the potential security vulnerability and you might find a leak in this barrier. And actually, the last one is for all of you. I would really suggest you to try new open source tools. My journey here started by playing with Pipe Viewer for the first time, and then something just clicked, and I learned a lot of stuff doing that. So this story actually started with this part, with the intuition. And this intuition led us to these results. And Dean Koontz once said that intuition is seeing with the soul. And if you are part of this audience, I'm sure that you have a soul of a hacker. So trust your gut feeling. Thank you very much for listening until this point. This is, by the way, the end of the session, and I hope you had a good time listening. And I will check now the Q&A, and let's see if we have a few interesting questions here. Let's see. And sorry, it's gonna take a minute. Q&A. Okay, we have it. Okay, I'm sorry. I need to go over a few questions before I answer. Mm. Oh, so I see the first question is someone who didn't really understand the fact of sending malicious payload to target these named pipes. So I would like to first of all clarify that this communication that you saw here is between an internal process. It's not a communication from this VPN process to the remote VPN server. The only thing that we saw here that is actually that we can affect in this aspect is actually there are a few things. So first of all is the clear text credentials that we saw that we can get on a malicious server if we change the configuration. Other than that, actually, there are a lot of other registry values that are very sensitive in this aspect. You might have seen the server certificate, where you can actually inject the one that you would like to set there, but also you can play along and find a lot of different registry values that will affect all of this communication, including types of encryption and so on and so on. Okay, let's see something else. Oh, okay. So there's another question. Should I completely block DLL injection, or should I inject all DLLs myself to implement some sort of seal healing? So I would say that about the code injection stuff. So first of all, DLL injection is one way to go with it. Another way is process injection as the concept, process hollowing being one of them, and there are all sorts of other and new code injection techniques. So what I would suggest you to do is to actually use different tools and use it by yourself against your EDR to validate that it actually is blocking these operations, because each one of these different process injection techniques is actually working on uh, different system calls. So the logic is different, and you need to make sure that EDR blocks all of the different ways. Oh, that's a good question. How did you find the hard-coded encryption key? So I will go over it for 1 second again, and then I will have, I think, only one more question. So the way that I found it was, okay, I will start by explaining how my mind went with the problem. So I had a problem, the communication was encrypted. At this point, I knew that they already had to handle the message on the pipe. So I went on and looked for the right API call that handled pipe messages. Once I did this, I knew that at this point, all of the data was encrypted because that's what I saw. So from the logic of the application itself, I knew it had to try and decrypt this data before it can do anything with it. So I went alone in the reverse engineering process and checked all of the different functions that were called. And I checked which one was actually called when they verified that the opcode was legitimate. And that's how I found the encryption function. And within this encryption function, I found the hard-coded encryption key. Okay, so how easy was it to disclose a reporting process to FortiClient? Actually, it was fairly easy. They were awesome. They have this PSIRT team that you can send. They have this specific form in the website. You can send everything to them, and they are very responsive. They had the process with them was great. They did a great job, by the way, by fixing this. It wasn't easy because, as I told you, they made this custom security barrier, and now they had to change the entire design, basically, of their product. It's not an easy task to do, and they managed it. So, yeah, good for them, by the way. Let's see how much time. I just want to make sure that I'm in schedule. Oh, okay. A little bit over. I will take one last question. Okay, so I saw someone ask if Fortinet fixed these issues. So yes, from version 7.4.1. And okay. And why was one pipe communication was encrypted and another was not? That's a great question. I don't have any specific answer to it because I don't really know. What I can only assume is that they understood they have something sensitive behind it. Again, when you see the obstacle, you know there's a reward by the end of it. So my guess would be that they understood that there's something sensitive in 40 settings, right? It even says it like 40 settings you can understand, you can manipulate it. Like, I mean, you can, if you will manipulate it, you can change the settings. But with FCDB log, it sounds like just, okay, let's do some log shenanigans. And it wouldn't be so interesting. And when I looked at it, by the way, I thought I had a good lead for arbitrary read for files on the system. And I thought I had a good win there. But apparently it was just something that they had in the past, but they changed it. So what they did, they impersonated from the service of system, they impersonated themselves to the user that is signed on. So what happened was the part that was not encrypted was already examined, let's say, by other hackers and other security researchers, and Fortinet already closed a few breaches there as well. But I don't know exactly why they didn't encrypted this communication, for example. Wow, okay, thank you for all of these questions. It was really fun. And I really do want to thank you for your time. It was awesome for me to share this story with you. And I really appreciate your time and your listening. If you have a little bit more time, you can, of course, go to our website. We have a lot of other interesting stuff in our Pentera Labs blog. And the recording of this session, we will send it to you by the next 24 hours to all of you who registered with an email, basically. And yeah, if you have any other questions, reach me out. You can find me at labs@pentera.io. And thank you.